Thank you, sir. Wonderful. We had a very good participations. I would like all the participants to stay back, and we're going to have an interactive question answer. So I'll take the first question from Babu. Can you explain about the soil filling on the electrode? The first question can explain about soil filling on the electrode.
Soil filling on the electrode. Yes, of course. You see the resistance of the system. The resistance of the electrode is mainly offered by the soil all around the earth electrode. In an ideal situation, you have to fill the area around the earth electrode with good soil. It means without any rocks, without any sandy or something like that. You have to use good soil and fill up the area. But for a low voltage installation, this don't do it so carefully. Instead of making it so carefully, you have to make a careful TN system, which will be much more safer. In a large installation, substations and all, of course, you have to be very careful.
Okay.
Thank you.
I don't know this answer is relevant to today's this thing. Is asking Ramesh's Banerjee is asking how RCD protects electrical equipments in case of a fault.
Yes, this was explained already. Okay. This was already explained.
So I'll move to Abdul Aziz. Good morning, everyone. I'm okay in India. So can we get He's asking for the presentation. Could we have further link? Okay, too many questions. I'll remove that. Kalyan Srinivas question, dear sir, which standard have preferred for lightning arrestor HT and LT and earth pit, chemical powder not preferred in some industrial earth pit purpose?
First of all, I don't understand the question very well.
Which
but the question also disappeared.
Yeah.
One moment.
The top.
The question also disappeared. Okay, it is here. Yeah. Which standard are preferred for lightning arrestor, HT and LTF? I don't understand the question, Mr. Kalyan. Chemical powder not preferred in some industry earth pit purpose. Okay, this is not a question. I think it's a statement. Thank you. We will go to the next question.
Okay. Which system is followed in India, either TN or TT? Naga Prasad.
Yeah. See, if you look at the regulation and the IS 3043 or the National Electrical Code, from the rule perspective, TN system is mandatory. That itself, within the consumer premise, it is TNS. And at the public distribution, it can be a TNCS, TNCS with PME. This is what is written in the regulations and rules. But TT is a kind of TT, not 100% good TT. A kind of TT is followed by the utilities. Also in industry, TT has been implemented and people claim the TT as TNS because most of the time the knowledge is a little bit bad in the subject. So TN is by rule, but by practice we do a kind of TT. It is not actually good TT. It is a kind of TT. People think that earthing is earth electrode in soil and try to put earth electrode everywhere. Thank you.
Okay, I'll go over a live question from Sajid Rotiwala. So you're allowed to speak now. You can unmute and ask Mr. Sajid. If you're listening to me, please unmute and do it. Are you there? Okay. I'll move on to Debashish. You can unmute and ask Debashish. You want to talk to Mr. Gopakumar? Please come forward. Debashish, are you there? Sajid, once again. Would you like to talk? No. I'll move on to Ganesh. Yeah. Who's this, please?
Mr. Dominic, this is there is a question from Mr. Ullas Vajre. I can see the question. So Mr. Ullas says, as per Mr. Gopakumar, electrical safety audit is useless and there is no such terminology. Instead, we use verification terminology and shall inspect and verify the installation. I don't agree with this argument because one very important point is missed out, which is identification of electric shock and fire hazard. So identification of hazard and mitigating them can definitely minimize the risk of shock and fire hazard. That's the purpose of safety audit. Verification, etc., is second stage. Mr. Ullas, if you are interested, you can unmute, or if you can allow, we can unmute Mr. Ullas, and
Yeah,
probably we
Ullas,
can have a
would you
small
like
discussion.
to come on to the, if you raise your hand, I will take you on the call. Yes. So Ullas, I'm allowing to talk, allow you to talk. So could you come online, please? Ullas, could you come online? Ullas was right.
I think he cannot unmute because, yeah, now he can. So Ullas, you have to unmute and speak.
Am I audible?
Yeah. Come on,
Hello.
Ullas. Yeah, you can.
My point was actually this verification of the installation, as Mr. Gopakumar has pointed out, has to be done in the initial stages, first of all, to verify all the parameters are in within the permissible limits. Now, in the running factories or running facility, when you talk about safety audit, it basically point out to one fact that first of all, we have to identify the basic shock and fire hazard related to the installation. So nowhere it is mentioned as per Mr. Gopa Kumar that the safety audit should be carried out. But we have been carrying out the safety audit for last more than 30 years, and it is serving the purpose also because apart from this audit, we carry out actual measurement. We see the condition for overloading of any circuit by actual measurement of the currents, etc. So it serves the purpose to my knowledge.
Can I answer, Mr. Ullas?
Yeah.
Yeah, okay. What you are saying is periodic verification. There is
Yeah.
nothing called audit again. This is called as periodic verification. Verification is required during the initial stage, which is called as initial verification. You can also refer to IS 732 for this particular purpose, or the IEC 60364 standard. The periodically what you are doing is called as periodic verification. Now, all the verifications 10 plus 18 is not possible in the periodic verification. So here you have the freedom to find out the kind of deteriorations which you are expecting in your industry, and you can list out probably instead of 28, you can list out, let's say, 5. And this, whether to list out 5 or 7 or 8, depends on the kind of the industry and the kind of appliances which you are using, also the kind of application. Now, to clarify this particular part, in the upcoming National Electrical Code, we have included a table, the recommended period of periodic verification. So sometime in the upcoming NEC, we also used the word audit, whereas in the other standards, the word electrical safety standards from IEC, especially IEC, you cannot see the word audit. We have included the word audit because this is the word which we generally use in that point of view. But what you should do in an existing industry is periodic verification. Now, the kind of periodic verification which you are supposed to do depends upon, as I said, it depends on the type of the industry. Now, by making an audit, let's say running around, by measuring earth electrode resistance or PPEs, that is not periodic verification. For periodic verification, you have to do, say, for example, RCD test. If you have an RCD, after 2 years, we don't know whether it will trip or not. You have to do a test. So
Yeah.
before making a periodic verification, you have to list out the type of periodic verification required and then do it. This is how it, I hope it's clear.
Even during our safety audit, we carry out all these measurements to re-verify the fact. But apart from this, I tell you, testing is one part. But what about the real practical problem at site, which you visualize? Like you have shown the photograph, there are nobody put proper landing termination. All the unwanted cable holes are left open, through which a rodent can enter, and it can lead to flashover and subsequently fire. So all such things somebody has to identify first and rectify. So that will definitely minimize the risk, will it not?
It is what I told you. There are 18 inspection points. One of the inspection point is what you were saying exactly. So these are included already in the standard. Only thing
No,
is
it is
we
there
don't.
in IS 1646. If you refer, everything is listed in that. How the installation should be. So if you carry out audit as per IS 732, IS 1646, NBC, definitely it will serve the purpose. Only thing is that in India, we don't have verification terminology that prevalent now. People are well accustomed to audit, so they call it safety audit. This is what I wanted to highlight.
No, correct. But please note that in the upcoming standards and regulations, it will be more and more verification. The word audit will not present.
Yeah.
I hope you understood. So
Yeah, very true.
auditing, for
But for
example, if
that,
you
we
have
need to
1,000.
create awareness among the industries and among the end users, where nowadays this safety audit is very prevalent. If you talk about verification and measurement, they may not agree. They will say, no, we want to carry out audit only. So this is the problem.
Okay, anyway, it is it is anyway. See, the idea of our webinars are to tell people what exactly is written in the books and standards and how it has to be followed. I hope we are doing that particular purpose. If somebody wanted
Yeah,
to
yeah,
use
very true.
only
Yeah.
audit, that it's all depends on the client's users. We
Right.
cannot
Then we'll
enforce
have
it.
to, I think, educate the people regarding verification and
Yeah,
inspection instead of using safety audit term.
yeah,
That's all.
Good.
yeah.
Okay, I'll move
So
on
thank
to
you very much.
Debashish. If
Let
you are
me
there,
second.
you can unmute Debashish or Sanjay. You are already unmuted, so you are
Yeah.
welcome. Sanjay, come on, Sanjay.
Can you hear me?
Yes, Sanjay.
Yeah.
Yes.
Yeah. Gokumar, in fact, I agree that in industry, the TNS system is very effective. And I have seen that in TNS, apart from the conductor, which is from the lower, low voltage installation, the conductor is going back, earthing conductor, or we can say P, protective earthing conductor, which is going back to the source. But still in between, consultant provides some, again, impedance, they connect back to that PE conductor. Was it exactly how it help it out by providing additional bit in between?
Yeah. You see, once when there is a current flow in the PE conductor, there is a voltage created on the PE conductor at the downstream. This potential drop on the PE conductor, it can create a shock hazard. So ideally, inside an installation, the maximum allowed shock voltage is less than 50 volt. So, in order to reduce the voltage less than 50 volt, we have to make a protective equipotential bonding.
Okay.
Now, instead of protective equipotential bonding, if you connect the earth, this P conductor to further earth electrodes, number one, it is of no use actually. Number two, if your P conductor is running on the soil, running above the soil in a place where people may touch, in that condition, of course, you have to make it to the soil. Let's say public distribution where the P conductor is connected to earth electrode. That is a good method. Whereas for industry, you have a P conductor inside your factory, taking another wire and connecting it to the earth electrode is not correct. You should connect it to the metal structure of your building itself.
Okay.
I hope I answered.
I will go to Parameshwar. You are allowed to speak now. You can come on if you are there. Parameshwar. Okay, Sajid, are you there? Okay, I'll go to the question box. Those who raise the hand, please be available to come on live and ask the question. So if you're not online, you can remove your hand which you raised so that I can continue with the question. So Muralidhar is asking, can we have the
Sir,
list of protection? Sorry?
सर
Who's
साजिद
this?
मैं बात कर रहा हूँ।
Sajid, go ahead, Sajid.
हाँ सर, थोड़ा गवर्नमेंट हॉस्पिटल का थोड़ा कम लगा है मेरे को, तो इस बात से मैं थोड़ा पीडब्ल्यूडी ऑफिस जा रहा हूँ।
हाँ,
ट्रैवलिंग में हूँ थोड़ा।
अच्छा। कुछ अब पूछ सकते हैं, अब क्लियर है?
हाँ क्लियर है सर, सब सुनता हूँ।
हाँ,
I think he don't want to. Maybe by mistake he has raised his hand.
Okay. So I'll go on to Muralidhar BK Krishna is asking, can we have the list of protection of an industry and domestic installation? What is protection? Okay. Is there anything that data is
So he's
available?
asking the list of the verification, list of the periodic verification for an industry and domestic. Of course, it depends on the type of industry. If we have a detailed details of the industry, then it can be found out. For domestic installation, of course, the small tests which will be, you can refer to the upcoming NEC. These are very well included.
Okay, Vilas is asking, what is better, chemical compound or salt plus carbon plus soil for earth weight?
Good soil.
Hmm.
Good soil with a resistivity of, let's say, 40, 50, up to 100 ohm meter, lesser than 100 ohm meter.
So Abhishek is asking how to save humidity of lightning arrestor if entry to the humidity in lightning arrestor.
Actually, that is not today's subject. Probably we
I
can
know.
discuss it on another day.
We'll go
He's
on.
asking about the high voltage lightning arrestor outdoor where the humidity is entering. So probably
So
another
we'll
day.
skip. We'll do it from the next time. So, Tippa Butler in the earthing system design in substation in TT system. What is the recommended split factor to be applied?
Loop factor will be applied, is applicable only in case of a TN type of system. In case of TT, 100% fault current has to flow through the grid only. There is no metallic fault return path. So split factor is applicable if you have a metallic fault return path in addition to the grid. Hope it's clear.
Okay, Smriti Ranjan Pradhan is asking, sir, as per your presentation, the earthing zone is up to 7.6 meter from the earth electrode. But in substation earthing, the distance between the electrode is 6.5 meters.
Mr. Smriti Ranjan, actually, I referred to a particular table from the IEEE 142 standard, where for a typical soil, they have, or for a typical soil resistivity, they have mentioned it as 7.6 meter. And this 7.6 meter is not true in all the soil. It may vary. It vary from place to place. So in substation, if you are using earth electrode, between earth electrode, if you have 6.5 meter, actually, you should keep 2 times the length of your earth electrode. If your earth electrode is 3 meter, then 6 meter distance is ideally good. But the standard also, keeping 2 times the length is very difficult. So you can also use it 1 time the length. But for better result, keep it to minimum 2.
So Dinesh Sundaramurthy is asking, how can I verify ELCB function when it is installed in an equipment?
I don't think that ELCBs are installed nowadays in the equipment. Probably if you have a very old equipment with an ELCB, but ELCBs are not there in the market for almost now, I think 15, 20 years. If you are asking about the RCD, then in the market, you have to buy an RCD tester. There is a device called RCD tester. It looks a little bit bigger than a multimeter and you have to do the test.
Okay, Abhinav Mishal is asking, what is the recommended rating of RCD in wet area?
Yeah, it is even in some places, some location, it is 5 milliamperes. But nowadays, more than RCD in a wet area, let's say, for example, bathrooms and all, electrical installations of SELV or less than 25 volt AC has been recommended. But if too specific to the question, of course, it depends on the type of the area. Even 5 milliampere or even 10 milliampere is necessary in some places.
Pankaj, sir, a lot of people are asking which is better, ELCB or RCB? This is this question keep coming.
Sir, RCCB is better. RCCB is better. I also think that ELCB is not available in the market. ELCBs are nowadays not available in the market. Probably if somebody may be making it, I don't know. But RCCB is better. Use RCCB, not ELCB.
So Sitaram, the last question of the day, we are almost 12:27. Sir, if there is no direct connection, MET between system earth and the load machine earth, but connection between them is via LT cable armored, then can it be called TNS system?
It can be called as TNS system, but the armoring may not be able to withstand the fault current. So in case of a fault, your entire cable may get damaged. So this is not, it is a TNS system, but this is not the safest system.
So Abhinav saying in market is 5 milliamps and 10 RCD is available. So RCCD.
Yes,
so
these are available. 10 milliampere RCCB is available, but not across the counter. You have to place a special order. Of course, these are available.
Okay, that's we end with the question answer. I'll take Parameshwar. If you are there, the last question I take live is from Parameshwar. If you are there, I'm going to asking you to unmute and talk. Okay, I'm going to close the live question.
Pauser is also there.
Okay, Apaya. Okay, sir, you can come on line, sir.
Good morning. Good afternoon, Mr. Gopal and Mr. Ramne. Do you hear me?
Yes, sir.
Yes, sir. We can hear you, sir.
Okay, it's a very good, nice webinar conducted by Gopal. And I would like to add a few points to supplement to strengthen his the queries raised by several participants. First of all, I would like to add one important point that NFE has to take up. That is, for the initial design verification, we require fault level. But the fault level is available with the Discom people. It is kept as a secret. It should not be kept as a secret. You should be transparent. Based on this fault level only, the consumers will have to design the EHV installation and the downstream protective gears. So it is of a mutual interest between the Discom as well as the consumer. In my opinion, the Discom is having such a wonderful evaluation of fault level with reference to the growth of the system. We should get it. And another point I would like to add with regard to the chemical earthing. The thing is, for example, a pipe electrode in a soil resistivity of 100 ohm meter, if you use a 3 meter long and 38 mm dia pipe, it will yield 25 ohm. Suppose if you use a strip of 5 meter long, because strips we are using invariably for interconnections, for interconnection of earth electrodes, for interconnection of switchboards and distribution boards with a switchboard. But what we do is we use the strip above in the trenches, above the ground level. If we exploit these strips, we can better have a very good earth resistance value. For example, a 5 meter long and 6 centimeter wide strip, if it is buried 75 centimeter deep or 60 centimeter deep, it will yield a 23 ohm resistance in a 100 ohm meter soil resistivity. It's a very good thing that is available with the engineering practices as well as IS 3043. And another thing, as Mr. Ullas raised a very valid point, because RCCB functioning and impedance, it is very difficult to have it done for 100% of installation in every premises. It can be done for small domestic or small areas. For such a very big installation, we can't judge the earth loop impedance of each and every circuit. It may be in the thousands of such circuits will be available from every OCPD. So we require a mutual acceptance between the auditor and the consumer to identify some areas And the auditor also, during his audit, can suggest, can undertake suo moto certain areas for further investigation. For example, in an audit, we wanted to rectify the echo machine in a hospital premises. But what we have done is, actually that
you have to mute
machine,
this. Yeah.
I see. It ended up with more than 2 hours time in identifying the actual cause. Finally, we identified it's not due to the conductor emission, it is due to the electromagnetic interference caused by some other land equipment. So there are a lot of areas only the auditor can identify. We can't fully expect the engineers. They should, of course, do the periodical verification 100%. And any subsequent verification, only some important areas alone can be practically done by the auditors. That's what I concur with Sri Ullas. And another question raised by Mr. Krishna and other things, and some other people, there is a difference, there is always a doubt whether the TT or TNS. In every industry we are having, we are claiming that we are having a TT. But as one person, Mr. Krishna pointed out, it is not an efficient TT. It also ends up with the cable armor connection and bus duct earth flat connection, transformer neutral to body earth connection through inefficient, inadvertent or fixtures connections that we never know that it will end up with a TT. So ultimately, end up with a TNS. Ultimately, what we say is, we perceive in actual reality is, every TT system is not done 100% perfectly as TT. We never allow the TT earth fault to be passing through the general mass of earth. It does have parallel path through the weak connections through cable armor or bus duct or all the metallic connections. As a result, we are not in a position to correctly coordinate the OCPD. So these are some inputs that I have to put up to the forum. Thank you, Mr. Dominic.
Thank you very much, sir. Actually, we think that our installation is TT. Actually, it is an inefficient TNS, or sometimes very inefficient TNC as well. Because nowadays with the digital grounding, there is a device called digital grounding device, which is installed in a lot of IT industry, especially near to the sensitive electronics, BMS rooms and all. Even with such kind of things, we are actually changing TT to TNC. The whole installation becomes TNC. So inefficiently we are doing. Thank you very much for the input, sir.
Thank you.
Over to you, Mr.
Thank you. Thank you so much. We had a wonderful participation, good questions coming forward. And as I said, this is the last series for the year. What Mr. Gopakumar we are discussing is next one, probably in the month of January, we will be doing especially for the healthcare for biomedical engineers. So for healthcare, because there is a lot of concern has been raised, there is static current, there is shocks at the OT room and OT table. So we are associating with the CAHO and the HPI, and we will be the next webinar will be addressed to the Healthcare Institute. So we will be doing that. And also we may have our first physical seminar in Mumbai, that's planning under the preparation. So we will let you know, since we all have a very good database, you're all there in our database. We will keep you posted about the next year plan of action. There'll be much more greater learning and awareness on electrical safety coming, and Mr. Abavu and Mr. Gopakumaral, as you know, we'll be launching the association officially very soon, and we'll play an important role to make our nation electrically safe nation. So that's the new code is coming up. So a lot awareness happening. So very nice to have this initiative coming out from Mr. Gopakumar, and I'm sure the learning and understanding will help the nation to become electrically safe nation. So wonderful, and thank you so much. I want to thank Mr. Lakshmi from the back end who's supporting, and wonderful Happy New Year. Merry Christmas to all of you. Next Sunday is a Christmas for us, and also stay safe. Have a wonderful year end with your family, and enjoy the great weekend today. Over to Gopakumar for his final word.
Yeah, thank you very much, Mr. Dominic, and thanks for all the participants. Have a Merry Christmas and Happy New Year. We will see in the year 2023 with a new subject. So until then, goodbye. Thank you so much.
Thank you. Bye bye.